So here we are going to see some interesting patterns. Say one for one, we are drawing one star, and in such a way we can draw patterns. We can draw the number which forms a triangle. For example, 3 forms a triangle and 6 forms a triangle this way. And now if we see 10 also forms a triangle. So if you total the number of stars in a triangle, it will count out to 10. I'll draw one here. Now if you say this is number 1, this is number 3, and this is number 6, and this is 10. So we can consider such a series. In this series, if we take first and second number, the consecutive numbers, first and second or third, if we take such numbers which forms triangle, the numbers which form triangles, then, and that too consecutive, then that forms a perfect square. If you add that two numbers, 1 plus 3, it is coming out to be 4, which is a perfect square. Here I'm missing E. So, okay. So, next is 3 plus 6. If you say 3 plus 6, it is coming out to be 9, which is again a perfect square. Now, see this two. 9 and 10, they are also consecutive. So, 6 and 10. So, if you said 6 plus 10, 16, which is again perfect square. Now, again, we will see what is a perfect square before going further. So, here 4 is a perfect square of 2, like 2 square equal to 4. 9 also a perfect square, that means 3 square equal to 9. 16 is also a perfect square number. 25 also a perfect square number. 36 is a perfect square of 6. 36, 25, all these numbers are perfect squares. Perfect square number also you can say. You can also say perfect square number. Now we are going to see numbers in between two consecutive perfect square number. Let's say 3 square equal to 9 and 4 square equal to 16. Now if you say these are consecutive squares, 3 and 4. Now if you say how many numbers are there in between these two perfect square numbers, how can we find out this? Let's count. 10, 11, 12, 13, 14, 15. Okay. So there are 6 numbers in between these two perfect squares. So we can put it in the formula 2n. This can be written in a formula. So this can be generalized, where n is the smallest square, 3. Okay. Now difference. If you calculate the difference between these two perfect squares, square numbers, 16 minus 9, you will get 7, not 6. See, if you count the above numbers, it is coming out to be 6. That is the number of square in between the two perfect square numbers, and this is the difference. So here we can say 2n plus 1 gives the difference, and 2n gives the numbers in between two perfect squares. Of it. Now let's see. Now let's counter check these formulas. 2n equal to 2 into 3. 3 means the smallest square, not the square number, okay, which is coming out to be 6. Now the difference 2n plus 1. 2 into 3 plus 1, that is coming out to be 7, which is perfect. Now we will see that if you keep on adding odd numbers, you land on a perfect square. Let's see how. See, 1 plus 3 equals to, these are consecutive odd numbers. So if we add these two, we are getting 4, which is the square of 2. So now if we say 1 plus 3 plus 5, these are 3 numbers and 3 consecutive odd numbers. So it will become 3 square, that is 9. Now if you say 1 plus 3 plus 5 plus 7, these are 4 consecutive odd numbers, so 4 square equal to 16. Now I'm adding 1, 1. In general, if I add n odd numbers, I'm going to get n square. Now what will be the last digit which I'm going to add? Till what number I have to add? So we can generalize that 2n minus 1. Say if we want 5 square, we will add how many numbers we will add? We don't know. So we will figure it out using this formula. 2 into 5 minus 1, which is 10 minus 1, that is 9. So till 9, we will add all the odd numbers. 1 plus 3 plus 5 plus 9, 7 plus 9, that is coming out to be 5 square. Let's see. 1 plus 4 is 1 plus 3 is 4, 9, 16 and 25.